Hello there and welcome to this course on data analysis with PySpark. My name is Valentine and I'll be your instructor. In this course, we are going to start learning about the learning outcomes of the entire learning experience. Then after that, we'll talk about important data analysis with PySpark concepts. Then later, we'll also get to talk about why would we want to learn about those concepts. After that, we'll get to go into a practice session where we will use PySpark to implement those concepts. So we will provide you with examples, that's code examples, as well as challenges to just help you be able to acquire those skills that we will have sought out to have achieved by the end of the learning experience. Then towards the very end, we just talk about the next steps. I mean, what would be the most appropriate step for you to take once you've learned concepts in relation to data analysis with PySpark. So let's get started. By the end of today, or this learning experience, we expected to have achieved these learning outcomes. We should be able to recall key data analysis with PySpark concepts in the context of data processing. We should also be able to describe the benefits and limitations of PySpark to make informed decisions about its usage in large-scale and data analysis contexts. We should also be able to perform various data analysis techniques using PySpark with the goal of extracting valuable insights from datasets efficiently. And lastly, we should also be able to derive insights from data analysis results, generally to be able to inform evidence-based decision-making and policy formulation. Starting off, what is data analysis with PySpark? This is just a process that involves using the PySpark API, which is a library in Python that integrates with what is called Apache Spark behind the scenes. And the idea of, behind this particular process is to use that PySpark API to perform various data manipulation, transformation, aggregation, and statistical operations on large-scale datasets. And this tool, generally, PySpark works by distributing data across multiple what are called nodes. You can think of them as just machines. And you're able to process that data efficiently in a parallel strategy, in a parallel format. And this still ensures that you're able to use what is in-memory computing, and you're able to efficiently process data in a way that large amounts of data in a way that's quite effective. You can think of Apache Spark. Apache Spark is the actual tool that would be in question here, but now we tend to use PySpark to be able to integrate with Apache Spark. Just to explain a bit easier, to make the explanation a bit easier, you can think of PySpark. Let me just call it Apache Spark as an advanced tool for large-scale data processing. Not even an advanced tool, just a standard for or an appropriate tool. Let me just call it an appropriate tool for large-scale data processing. So normally when we are working with just data manipulation or data wrangling or data analysis tasks in data science or data analytics, and we are using a tool like a programming language like Python, we would use pandas. Pandas, we would normally term it as a standard for data manipulation when it comes to Python. But for large-scale data manipulation tasks, pandas does not perform in many contexts as efficiently as you'd want it to, and hence the need for a large-scale solution that allows you to pre-process or perform data manipulation tasks in an efficient way. That's where Apache Spark comes in. Apache Spark comes in, and if we do not want to work directly, if we have knowledge of Python and we do not necessarily want to learn a whole tool from scratch, then we can use a library or an API, more so a library, Python library that integrates with now that technology. So for example, if we have a large data set, a really large data set that contains transactions data, maybe from maybe a telecommunications company, because they are one of those types of companies that collect a lot of data about their customers, and also the infrastructure. In such a situation, instead of using the pandas library, which of course you could use, but the only problem is that at some point you might realize you're using a lot of resources, computing resources. You might end up paying for so much in terms of cloud, in terms of having so much in terms of cloud costs. So you could decide to use a tool like PySpark to be able to perform just some important data manipulation techniques on data that you're much more interested in. So behind the scenes, PySpark leverages what are called resilient distributed data sets. These are data structures that are able to efficiently work with data, and they are the fundamental data structure. There are many data structures in Python, and you could talk about quite a large number of them. And as a way of just ensuring that the data that you're working with is which is in large format, is does not come by the challenges that you would get if you were to work with a lot of data, especially lots of time when it comes to pre-processing. You might even end up having systems that do not respond if you have a lot of data, sometimes because of the fact that a lot of data would be processed. You might end up having maybe some of those processes stopping because of certain limitations within your computer or your infrastructure. Behind the scenes, resilient distributed data sets allow you to be able to have solutions, data analysis solutions that are fault tolerant, that are distributed across multiple nodes in what are called clusters. And you, as a result, you're able to have just efficient transformations on that particular in actions on the large scale data that you're working with. So in simple terms, just think of PySpark as a tool that you can use if you have Python knowledge, and that would allow you to be able to handle a lot of data. It's an important skill, especially for modern data scientists or data analysts, largely because at some point you might want maybe to work maybe with a lot of data, whether you're employed or not. It could be that you need to collect maybe data from a certain repository that has a lot of data. So PySpark might come in handy as opposed to generally using pandas. So that's just a quick overview of what PySpark is, and we are going to be learning about various data analysis concepts that would come in handy in your in any sort of projects, basic projects pertaining to just working with large data. So in terms of benefits that you'd get from using this solution using PySpark, you're able, of course, to use PySpark on large scale data sets that exceed memory capacity of a single machine. You're able to also leverage in-memory computing and optimization techniques as a result of using PySpark, because behind the scenes, you'd be using resilient data frames. You're also able to integrate your solution with other Python libraries, because of course, when you're using Python, you also are able to import other libraries that might come in handy, maybe for even visualization, seaborn, or machine learning, such as maybe scikit-learn if you want. But in some other contexts, in some contexts like even machine learning, you might also want to use PySpark's tools also for machine learning. There are also related tools that would also help you to be able to leverage distributed computing still in relation to PySpark that you can also integrate them into your solution. You're also able to benefit still while using PySpark because you end up having a fault tolerant solution. Again, because of those resilient distributed data sets, data structures. And also at the same time, you're able to leverage the fact that you can perform parallel processing, which would generally mean that you are able to perform multiple tasks in a short in a short period of time, as opposed to using the traditional approaches that come with the use of traditional tools like pandas. When it comes to use cases, these are just some good examples that might give you an idea of situations where you might want to use PySpark. Again, PySpark is not for use on everyday basis. If you have small scale data sets, maybe a data set that maybe just goes to GB 2 or 3 GB, you could use pandas. But when it becomes a bit more, then you might now think about now using tools that are much more appropriate for that, such as PySpark. So one use case would be to use maybe PySpark to read and process log data in parallel across a cluster, and you would perform aggregations, calculate metrics, and probably even visualize insights. You could also analyze customer transaction data to segment customers based maybe on purchasing behavior. This is where the likes of clustering also comes in. PySpark also provides not PySpark itself, but PySpark has related tools that also allow you to be able to perform machine learning tasks, unsupervised learning tasks. You could also be able to analyze transaction data to also discover associations. This is also an unsupervised learning task. And the idea would also be to optimize maybe product placements or promotions. So again, this is on the consideration that you are working with a lot of data. So any case where you feel like, by the way, if you're lost, you could always just rewind the stream or the video, and then you can always just quickly catch up. The workflow generally when it comes to working with PySpark, for traditional tools like pandas, I'm calling them traditional tools because it seems as if, but I would just call them traditional tools for just ease of just learning in this case. If you're working with a tool like pandas, you just import the necessary library, then you just read the file, then you explore it, then you export it after. But for PySpark, you of course need to import the necessary library. You could also, actually, in many cases, you would need to install it, then import it, install the PySpark library, then import it. Then after that, you create what is called a Spark session, which is just an environment that's tailored for a solution that you're building. So it's like if you are going to be writing code for maybe performing a certain type of data analysis, then you would need to create a Spark session, which would just allocate resources for that particular resource, for that particular application. Then you load the data set that you're going to be working with. You can use different formats. For our case, we're just going to just use the most basic format for just learning. But again, you could always explore the documentation for just extensive data sources that you might want to import data from and perform data pre-processing. Explore data. You explore that data set that you want. It could be in just checking the first file records to just understand the structure of the data set, cleaning and transformation, performing a whole lot of data tidying work. Then after that, you aggregate the data, you get the data that you want from the data that you had imported, and then you export that data somewhere that other stakeholders might find useful, or you could also export it for another type of analysis elsewhere. Then you stop the Spark session. So when you started the Spark session, you allocated resources to the solution that you're working on. But when you stopped it, it means that the resources are now going to be reallocated elsewhere. So that is something that you're going to be seeing. It's just a simple workflow example that we are going to be undertaking in our work. Something to note in terms of limitation. you might get to see that when you're working with PySpark. As you continue working with the tool itself, you might realize that it doesn't have a lot of data in exploration capabilities. Some of the tasks that you'd probably quickly perform with a tool like Pandas are sort of somewhat limited, like even data visualization capabilities. You then need to just use tools which are related to PySpark, maybe such as Seaborn, still which is a Python library, or other tools that you feel that seem appropriate for such situations or data exploration. In terms of debugging and error handling, sometimes it can also be difficult, especially when you are new and you're not sure what would be happening. But again, you could always just Google around, or just get some support from just different support platforms that can be able to provide you with just some clarity on what exactly is happening there. Could also use some of these emerging AI tools that would provide you just clarity on that. So at this particular point, I'm going to ask you to visit the resource link in the description of this video. Then that link should take you to a page that looks like this, and then you can download the practice resource. Once you have downloaded this sample practice resource, if you're an Afterwork member, again, you have a practice resource. You don't have a sample one, you have the full resource that you can use. The full resource has just challenges for each section, but the sample doesn't. It only has a few. And we would encourage that you also just consider also becoming an Afterwork member and getting all the resources that you would need for your learning journey. All right. So yeah, once you have done that, if this is a sample resource, this is the practice. I will use the practice one. So let's get started by clicking on File, then Save a Copy in Drive to save a copy of this notebook. And then once you have done that, it will open a new tab with the original copy. And you can close the original one. So you can use the new one that which is saved actually on Google Drive. And then once you have done that, you can click on Connect on the far right. I shouldn't actually click on Connect on this one. I'll just open mine in playground mode, but you don't have to because I don't want to make any changes to this copy. So by the way, if you feel like I'm too fast, feel free to pause the video and then, or to rewind the video and then you can come back. All right, once you've saved your copy in Drive, just click on Connect. All right, it's connected. Then let's import the PySpark library. So we'll just say install, pip install PySpark. Should take just a few seconds to install. Should take a few seconds and then we should be ready to go. Once we have done this, we are going to import the Spark session class, which will allow us to be able to start a Spark session and then also be able to also close it later. So it just means to allocate resources that we would need for such a case. So yeah, then you can always just pause the video and resume. Yeah, if you feel like we are too fast. All right, I'll just click on this. Okay, it has already installed. Well, it's not completed the task. It will take a few seconds, but yeah, so let me, this other side. All right, we are good. So I can click on import Spark session, which I'm good. All right, we'll start off with our first task of importing maybe data from various data sources. Our focus will just be to learn how to import, but you can always explore this PySpark documentation for all those other functions that allow you to import data. So let's just quickly import data from a CSV file and see how that works. And again, CSV files could be large, and you could use also PySpark to be able to sift through those large data sets. In some situations, when you're working with a tool like Pandas, you might get to a point where you need to even just use what are called chunks, like, split the data set into just chunks and be able to read it. But when you're working with PySpark, you have a good idea of doing that. So you actually do not necessarily need to split. So you just work with the entire data set as it is. So assuming that we are working on, so initially, by the way, this is how we do it. We create a Spark session. So we create a variable, which will now have a Spark session. Then we use a Spark session class, and we would want to use this function app name to be able to define the name of our Spark session. We just give it just reading data, and we say just get or create. So this particular line of code will create a Spark session that will just be specifically for this particular task that we want to perform. We want just to read data from into a data frame. Normally, a data frame in this context would be a Spark data frame. So that's what we want to do. There are pandas data frames. They are just the data frames. The term data frame is usually a common term, but it's usually that when we work with data frames. So for example, if we are working with pandas, we just call it a pandas data frame. If we are working with some tool, like maybe there's another library called VAES, which is also a library that we can use for working with large amounts of data. There's VAES, by the way, that's also another tool that we could have learned instead of PySpark. We could have also, called our data frame a VAES data frame. All right, so by the way, the tool it's VAEX, not VAEX, VAES. VAEX, it's a VAEX, so you could always explore that later. So let's read this data. So we can read the data directly from a URL, but it's a bit more complex with PySpark. You would have to download this file, then import it, or you could still use a tool like what is called requests. The requests library, there's another tool called requests that we tend to use to just fetch resources from the web. You could use it, but for just ease of learning, without just having so many tools flying around in a learning experience, we're just going to focus on Spark. You're just going to simply download the file that we have shared with you. So this one, you will need just to download it and then upload it on Colab. So on the far right, when you click on this particular icon, so if you click on this icon, you should get this section over here. And our task for each and every task that we're going to be doing. So you're going to be having like, for each section, you'll need to import it. So you'll have like, I don't know, maybe 10 or 15 data sets, more than that, for this learning experience. So to download this, you can simply highlight this particular URL, then open a new tab, then paste, then press enter, and it will download on the far right. It will download it to your downloads folder. You can do that. The other option would be to drag your mouse on top, or you can click the link just once, then drag your mouse on top of that link, and you should see a follow link. When you click on that, it's going to open a new tab, but again, it's going to just download it. You don't need to visit the link anywhere else. So we have downloaded it. Then to upload it, you need to upload it to Colab. You need to click on this icon on the far left on the files. Just click on that icon. It will give you a pop-up. You're not seeing that pop-up on my window because I haven't shared my entire screen with you. I've only shared my browser screen with you, but the pop-up window is from the system that I'm using. But yeah, so I am going to just upload that file by clicking on open, then to just give me a warning, which just tells me that if the Colab session goes off, I won't be able to access the file. They'll disappear and I will need to upload them. But yeah, so I have my file here. So when it's here, then it's good now. So I'll just now read the data and the CSV dataset, which is here. I will use spark.read.csv function, and then I'll give the name of the file, which is the one here. Then I will set the header, because initially when you load the dataset, you won't get the header or the column names. And I'll set it to true so that I show that. And then I can show the first 5 rows of that data frame as shown. I can set it maybe to 6 to 7. You can but you have to use the show method, or the show function. And then you stop the Spark session once you have performed the task to just reallocate resources, to release the resources that this particular application will be holding. So let's run that. Should take a few seconds. If you run this without uploading, again, you'll get an error. So you need to re-upload again. All right, awesome. So this is our output. This gives us a Spark data frame. It's just the tabular structure that gives us the first 5 records of the data set that we have here. ID, product, category. It just gives us just a snippet of the data set so that we know what exactly we are working with. So in many cases, you would actually need to just import data. So at this particular point, I'm going to ask you to pause and work on the challenge. The challenge that we are going to be working on is this one. So you'll need to read the sales data from this file. So you need to create a Spark session. Feel free to copy the code and paste it here. Read data from the URL. You can also copy this code here, but again, change the name of the file. And you can download, you need to download this file. So drag your mouse on top, or you can click on it once, then click follow link. It should download the file. Then you can upload it. Then once you have done that, you can upload it, show the first 5 rows, then stop the Spark session. All right. By the way, pause the video. Then once you're done, you can unpause the video for each section, by the way. For those who are Artwork members, you can also verify your solution with the solution notebook that we have shared. So this is the solution for that. All right, awesome. Let's continue to the next step. We've gone through that. Let's continue to checking the size of the data set. So assuming that you've already checked the first 5 records, but you'd want to see how big it is, how many records you have in that data set. So for each and every task that we are going to be doing, note that we are going to be creating a Spark session and then closing it. So we'll start by creating a Spark session, give it a different name, and then we load the data set just as we did. So I'm going to download this data set, and please bear with me. I'll be uploading those data sets every now and then. So yeah, so please bear with me. So let's see. Let's see. So yes, I've uploaded now this data set, so which looks like this. So this is the data set, and you can also do the same. Just download and upload it, and then you can use the count function to be able to apply it to the data frame. It's a Spark data frame, sales data, and you should be able to get the number of rows. And here we just use a print function to display the number of rows, and then we stop the Spark session. So we'll get the number of rows. The rows, we have 75 rows in this data set. Again, this data set is not that big. It's only meant for just learning purposes. But again, you might get lots of just big data sets to work with. And that would be the best use case for Spark, PySpark generally. All right. Pause the video and then work on the challenge. This is the challenge. Moving on, selecting columns. So in some cases, we would want to only work with a subset of columns. We wouldn't want to work with all the columns that we have in the data set. So what we might want to do is to just select certain columns, maybe one column. Let's first of all learn how to select one column. So again, we create a Spark session, we read our data and display it. So I'm going to display those. Yeah, okay. So I need to upload. If you'll get an error like this, like I have, if you haven't uploaded the data set, we need it to be here. So I could have decided to give you all the entire data set and upload it so that it can be easier to download. But it's, again, feel free to just download one by one. So let me just click on that and it should download. Then I can upload it here to. All right, so it's uploaded. Then I can just run this. This is the data set. And then we can be able to select the product column. So we want to work with only the product column. And we want to, yes, you can just without even putting a filter, we can just select just one column, by the way. But we might want even have to have a condition, which we are going to learn in a few. In my case, I could decide to just work with just one column. You know, it's just that column, and then be able to display it, and it will have all the records that I want. But again, this has, I think, 10 records. It's not a big data set. I could also decide to apply a filter, which we are going to learn how to filter for data. Again, if you run the cell again, you'll get another error that tells you Spark context should be created first. It's because when we run initially, this cell, this code was also run, so we stopped our Spark session. So we would need again to rerun and create the Spark session by running this code, and then being able to rerun that code. So here you can see we have fewer products. All right, pause the video and then work on the challenge. Selecting multiple columns. So sometimes you might want to select multiple columns, so just one. And also not necessarily even apply the filter. I applied actually multiple filters here. Again, that is an I oversaw that, but yeah. But generally, let's first of all download this data set. Downloaded it and upload it. If it's something, FV. All right, it's uploaded. Run this to be able to display that data set. And then we want to select product, category, price, and quantity. So I could even just remove this. I don't need that for now. We will get into that, but you might have questions about selecting. But these are the records. Again, this data set only has 10. I think you should have 10. If you had more, you'd have more records. It's only for learning purposes. All right. Run that, pause the video, and then work on the challenge. In some cases, we would want to filter for records. So we would want to filter for records maybe based on one condition, or just records that meet a certain criteria, because they would help us just focus on the subset of data that we need for our analysis. So let's learn how to be able to do that. I'll download this data set, the one that is here, sales OR 9. So I can just drag my mouse, then click on follow link, and then I upload it. Then once I have uploaded it, I will just run the cell itself to display the data set that I want to work with. So I want to work with only records with price greater than 200, and I can display them using just show and stop the Spark session. So here are the records that I want. And please note that once you have maybe filtered for those records, you could always export them to a different database. There's so much about data science, data analytics that we can learn, but we only take one step at a time. Like, for example, this data frame, you could export it to an SQL database or a MongoDB database, or, those are sessions that we will plan to do in the future. Just wanted to bring that out, because once you filter your data, you just don't want to just show it first. You want to make it, useful by simply maybe taking that data maybe to a database somewhere, or even just exploring it. But we'll learn how to export data. Pause the video and then work on the challenge. All right, moving on, we might want to filter by multiple conditions. Here we just have one condition, which we specified here. And you'll note, by the way, if you've learned about pandas, this even actually feels a bit easier, but it's okay. Let's now move on to filtering by multiple conditions. So if you have more strict criteria for your data, then you can follow this structure that we're going to follow now. So I've downloaded the data set, then I am going to upload it. Then once I've uploaded it, I'm going to load it, create a Spark session, then load that data set. And then I'm going to use multiple conditions. So this is my first condition. I wrapped it in parentheses. Here I don't wrap it. Here I did not wrap it. I'm inside with parentheses, inside the filter function. So inside it, and I also used an ampersand and sign. And also I wrapped the second one. I could also have another one as well. So yeah, then I filtered my data and displayed it. So this is what I have. Awesome. Pause the video and then work on the challenge. In some other cases, we might want to filter or sort, especially in questions that ask which are the top 3 or top 5 records, which are the bottom 3 or bottom 5 records. So yeah, so let's get to do that. So assuming that we have this data set, which we are going to sort, this data set that is written YBML, just downloading it and uploading it. All right, it's uploaded. Let me display it. I want to sort this data set in ascending order based on the price column. So I want the greater values over here than the other values going downwards, becoming small downwards. So let's sort this data set using that column. So this is what we have. So you can see that we've sorted by, actually we haven't sorted by price. Okay. All right. We can use a second method. I had overseen that. We can use a second method that we had. Actually, the method that we're going to use is actually this method that we are going to be using. So instead of sorting, I'll just copy this instead of rewriting it again. I had overseen that. So we use order by function, and then we state the column that we want to order the columns by. So then ASC to say that we want to sort the records by the price column values in ascending order. So if I run this, okay, I need to rerun the Spark session, create the Spark session again, then run this, and I should be able to, okay. It's giving me, all right. So I think there's something here. So I think I know this, what the problem could be. So when we are loading the data here, we would need to define the data types or to infer. It's usually called to infer the type. So we would need to read the data type, but set another parameter, infer type, to be to true. Should be, I think it should be infer type. Is it infer type? I think it's infer schema. Yes, infer schema. Sorry, schema. Yes, infer schema. So what this parameter does, it ensures that all the data types, all the columns have the classifications that they ought to have. If it's for numeric data types, they're all given the numerical data type. If it's for numerical or categorical columns, they would be given just string data type. So so we need to set infer schema. I'll make sure to update that in the notebook, and then here actually even before, what we had written before was actually okay. So here it was ascending. So if I run this, then I should be able to get the records in ascending order for the records that I have here. So they are arranged in ascending order based on the price, but I could have also just done the easier way would have been just used order by and just set it to just price. I can't run that again because I've stopped the Spark session. I would still also get the same outcome. So the idea is just to ensure that you have inferred your schema. You just said infer schema as to true, and you should also do that in any case that you in your work. So make sure that you ensure that you have set the infer schema parameter to be true. Yeah, so that's how you arrange the records in ascending order, and you can also apply this order by function to a data frame that you filtered, etc. All right, at this particular point, pause the video and then work on the challenge. In descending order, we can also do the same thing. So let me just download the file and then upload it. Where is it? Okay. Then I'll also add infer type, infer schema. You should have it because I've already updated the notebook. Run this. And this is what we have. So we want to sort the data in descending order by the quantity column. So for the quantity column, well, they are in ascending order, but we want to have in descending order. So let's run that, and we should be able to get the values in ascending order. All right, pause the video and then work on the challenge. Summary tables. So sometimes you might want to create summary tables out of a bigger table. So let's download this data set and then upload the data set itself that we've downloaded it. So then run this. So this is what we have as the record. So to create a summary table, so you can think of it as a smaller table, we have a group by function that we use. Then we set the values of the column that we want to be on the left, that's region. You also want to aggregate by salesperson, so we want region, and then other column that we want is salesperson on the on the one that's going to be on the right, and the count of salesperson per region, and also the count of price, which is the total price per region based on this particular column. So we want a summary table with region, each region, and then each region would be north, east, west, would be south as well. But now we also want to have the count of salesperson and the price. If we do not have this code, which will rename the columns, we will get to see that we'll have salesperson's count and price sum. So, but before I do that, let me just assign infer type, infer schema. I had forgotten about that. Let me reload it again, so that we have the correct data types, and then I can be able to now perform this. So I'll just comment this. No, I can just remove it for now, so that if I run this, you should be able to see that our outcome, it's a summary table, region, then we don't have south. Okay, we have sum price and count salesperson. But assuming we wanted to have the respective column names, that's where we would rename the column names using the with column renamed. So with column renamed function would replace this column name, which is this one with the value on the right. Then also we would also add another with column named renamed function. We would use it to replace sum price to total sales, and then we display the table. So I'll just rerun this again because I stopped this Spark session, and then I can run this. All right, pause the video and then work on the challenge. Data exportation. So once we have done our analysis, we might want to export data. So to do that, it's not that difficult. Let's just download this file and then upload it. Once it has downloaded, we're going to upload it. And this, and also load this and this. So technically we have, here we displayed the data here. I did not put in infer schema here because we're not doing any data pre-processing, especially for numerical data. But then once I had the data set here, I just use write.csv to write the CSV to this particular file, which will have this name. And I also want it to have a header, and that's what I do. And it shows up actually in the same directory as what we have here. And I could always just preview it and be able to export it somewhere else that I would want. But yeah, so I could even just say exported data.csv. Let me just rerun this again, sorry. And refresh that. So this would be the data that I would be able to have. But yeah, so yeah, you can always do that. Pause that and then work on the challenge. So yeah, I hope so far you were able to acquire those skills that we were meant to have acquired. So by the end of this learning experience, we were expected to have achieved these learning outcomes. So be able to recall key data analysis with Python, with PySpark concepts, be able to understand or describe the benefits and limitations of PySpark, and also perform data analysis techniques, which we have been able to do that, and also derive just the insights from analysis techniques. And the idea is generally to use this tool whenever you have use cases where using another solution aside from pandas is the only option, especially where you need to cut down on resources, computing resources. Then this tool comes in handy. In terms of next steps, as part of the next steps, we would think that once you have gotten to learn how to perform data analysis, you could still get to learn more about how to perform data wrangling techniques with PySpark. So being able to handle missing values, being able to rename columns, we've done that a bit. Being able to clean data generally. Once you've done that, you could now see how you can also integrate your outcomes, maybe your analysis that we have with other tools like pandas, how you can export data, maybe a summary table to pandas and also visualize it. So think about different contexts that would make sense for you and see how you can put this tool into practice. And once you're done with that, just think about machine learning, maybe still with PySpark. Could be that in some contexts it could also come in handy. All right, all the best in your learning journey. And if you did love this experience and you think that we should keep continuing what we are doing, be sure to give this video a thumbs up. It just tells us that we're doing something that is meaningful, it's valuable to you and to many other people. And if you'd want to be informed when we post such future courses, be sure to subscribe. And all the best in your learning journey. See you in the next course.